All rise, the Universal Court of Thermodynamics in session. The Honorable Judge Gibbs Street Energy presiding.
Be seated. Today's question, should this reaction continue spontaneously or should it be denied? Bring in the defendants.
The defendants, enthalpy and entropy, accused of taking place in this universe without permission. Permission? I am the universe spreading out. I don't ask, I expand.
And I am the energy stored in chemical bonds. I only wish to be released. We shall decide. Prosecutor Temp, please begin.
Entha, describe your role in a reaction.
Well, when bonds break, energy is absorbed, endothermic. Delta H is positive. However, when bonds form, energy is released. That is exothermic. Delta H is negative.
Jury, note that a negative delta H means that the system releases heat to its surroundings.
It's getting warm. The surroundings are heating up. Bonds form. Energy escapes. The system settles lower, like a ball rolling down a hill. A negative delta H favors spontaneity, Your Honor. Noted. But the equation has two terms, Entha. You are not the whole story.
Tropy, what do you bring to a reaction? Chaos. I am the number of ways particles can be arranged. Ice melting, solids dissolving, and water boiling. That's me, spreading into more microstates. A positive delta S means more entropy. Gases have more entropy than liquids, and liquids more than solids.
But if entropy ruled alone, every neat thing in the universe would fall apart instantly.
And eventually it does, Entha. Eventually it does.
Order in my court, or rather, disorder, but in controlled amounts. So negative enthalpy favors spontaneity, and positive entropy favors spontaneity as well. But what happens when they disagree?
Case 1. Enthalpy is negative. Entropy is positive. Both help. Delta G is negative and spontaneous at all temperatures.
Spontaneous at all temperatures.
Case 2. Enthalpy is positive and entropy is negative. Delta G is positive at all temperatures.
Non-spontaneous at all temperatures.
Cases 3 and 4, they disagree. In this case, temperature decides. In the equation, I multiply delta S. As temperature rises, my influence over entropy grows. Case 3. Enthalpy is negative and entropy is also negative. Spontaneous at low temperatures only.
Like water freezing into ice, releases heat, but it's more ordered. Happens only at low temperatures.
Case 4. Enthalpy is positive and entropy is also positive. Spontaneous at high temperatures only.
Like ice melting, absorbs heat but becomes more disordered. Only happens when the temperature is high enough. Neither enthalpy nor entropy decide spontaneity alone. See, spontaneity is about the sign of delta G. So I was wrong to claim spontaneity for myself.
And I was wrong to think that chaos always wins.
You are partners. Enthalpy and entropy, together, weighted by temperature, you guys determine the sign of delta G. Negative delta G, the reaction proceeds forwards. Positive delta G, it doesn't. And when the delta G is at 0, that means that the reaction is at equilibrium.
And remember, when life feels disordered, just blame the second law. It's spontaneous.